Okay, lesson 5.4 problems. So logarithms for more properties, more complicated situations with logs. If we have log base 2 of this expression here, they want us to rewrite it in this format. This is the way it looks like in Hawks. That's the reason why I wrote it like this. So we have to rewrite it in this format. So what you want to do here is probably take out a 4. So you're going to take log base 2 and then take out a 4. And you'd get 4x plus 3y. And by doing that, then you could use the log rule that we have, which is log of AB, okay? If it's the same, you could say that that's equal to log of A plus the log of B. So therefore, we can break this part up. This is going to be log of 4 base 2 plus log of 4x plus 3y base 2. And the reason why that's helpful is that this is going to simplify to a whole number. See, that's a box by itself without a log in it. That means that this is meant to simplify. So log 4 base 2 means 2 to what power equals 2 to what power equals 4. Well, clearly that's going to be 2. So log of 4 base 2 is equal to 2. So this part is a 2, and then you fill in the blanks over here. So it's going to be 2 plus log base 2 of 4x plus 3y. Very common problem in Hawks that you're going to see where they have a box by itself without a log. That means you're going to get a whole number here somewhere. And just remember how to change from log form to exponential form. That's how it simplifies. Now over here we're trying to use the log properties where we're adding and subtracting. So this is adding and this is subtracting, so we're going to have some addition there. So we're going to have ln 12. Now I'm going to rewrite this, put this exponent back up, plus ln x squared, and then minus ln y to the 5th. So what we're doing is we're putting this back up into exponential form where it's possible. Then we can simplify it. So since this is adding, it's going to be multiplying, so it's going to be ln of 12 times x squared, right? And since this part's subtracting, it becomes division down here. So that's going to be y to the 5th. So it's the ln, this entire thing. So the multiplication comes from this addition right here, okay, which we knew that from before. And then this is subtraction, so that's going to become division. And we have y to the 5th. So we put it back in this form, back up. So let's remember that. So y equals log a to the b. That equals b log a. And we can reverse it to go back like this as well. Okay, the next problem here, we're looking for the pH of a concentration of liquid, moles per liter, I believe that is. And this is a formula that's given to you. You don't have to memorize it. But just remember that the pH is equal to negative the log of whatever the concentration is. So this is obviously a very small number. So the log of something that's between 0 and 1 is negative. That's why you have the negative over here to make the answer positive. Remember, pHs go from 1 to 14 on the scale. So you just have to type in your calculator negative the log of, now this is scientific notation, so it's 3 zeros. So it's going to be 0, 0, or 3 spaces, sorry, 186. So it's negative log, negative. So it's negative log 0.00186. Enter that into your calculator. You should get approximately 2.7. So that's the pH. All right, there you go. Okay, so this is a nested log problem. Just be careful here. You have a natural log on the outside, a log on the inside. So this is a direct calculator implementation question. So if your calculator allows you, you can do it all in one stroke, ln, and then log of ln parentheses log 279 parentheses. Well, you know in common sense though that the log of 100 is 2 because 10 to the second power equals 100. So you know this is a little bit above 2. So this is like 2 plus, and this is ln of 2 plus. So you know this answer is going to be below 1 most likely. So directly type into your calculator and you should get 0.89. Do that on your calculator to convince yourself. Number 5 here, we have log of 0.392 to the 1/7 power. So we write that, this is log form, we're going to write that in exponential form. Okay, so sorry, there's the log form right there. We're going to write this in exponential form. That means you have 1/7. Okay, remember this equals x. So the base stays the same. the logarithm of the exponent is equal to 0.392, 1/7 to something, okay? And then you just follow through there, so you can bring on the power rule there. So you can bring this down to become x log 1/7 is equal to natural log 0.392. So the natural log has a base e, by the way. So the rule that we're using here is if you have log of a to the b, that's equal to b, bring it down, b times log a. So that's the rule that we're using right here. Bring x log ln 1/7. So natural log, I should say. So then x is going to equal simply the quotient of natural log 3.39 over the natural log of 1/7. And if you do that out, you should get an answer of 0.48. Make sure you do that in your calculator so you can get that answer yourself. Number 6, we have the log, L-O-G, of this information here. Now, look to see if you can take out a greatest common factor. That's the first thing I would do. And since this is adding, we know that we could probably break that down. So let's say log of 2, and break that down, take it out of 2 times 4x squared plus 8x plus 4. Oh, we can take an 8. What am I thinking about? We can take an 8 out. My bad. Not 2, 8. So it's going to be 8 times x squared plus 2x plus 1. So write that down. So it's going to be log base 2 of x squared plus 2x plus 1. So now that you have that, log of 8, so log of base 2 of 8 times this. So you can have log base 2 of 8, right, plus log base 2 of x squared plus 2x plus 1, which means we know this part's going to be 3, so it's 2 to what power equals 8, so this is going to be a 3 right here, so it's going to be 3 plus. Now, this is a perfect square you might recognize, so it's log base 2 of x plus 1 squared, so you can bring that 2 down, so you're going to get 3 plus 2 log base 2 of x plus 1. Okay, see that? So what happened here is that you take out the greatest common factor right there, take out that 8. That means you're going to have log of 8 base 2, that's going to be a 3. So that brings down a number right there. And then here, this is x plus 1 squared. That's a perfect square. So it's log base 2 of x plus 1 squared. And then you're using this rule again right here, this rule right here, where we bring that exponent down. That's what's happening here. And it's going to be 2 log base 2 of x plus 1. So that answers that question. So here, we're going to use this power rule. Or here, backwards. We're going to go from this point back up to here. So we can use that power rule both ways. So that means we're going to say log of x to the 5th, y to the 6th squared, put that 2 back up. That's what we're doing right there. Plus log, you'll see in a second, because it's going to be easy to multiply and divide out. So 1 over x is going to be squared. And then you're going to have minus log of y to the 8th. Yeah. Alright. So now we're going to convert this addition to multiplication. Well, actually, no, we can multiply this out. It's going to be x to the 10th, y to the 12th, right? And this is times, because we're adding, the log adding is going to equal to multiplication times 1 over x squared, right? And then you're going to divide by, what's this? Log of y to the 8th, so y to the 8th is going to go down here. So now we have some terms. So we have x to the 2nd we can divide out. That becomes x to the 8th up here. And then we have y to the 12th and y to the 4th that's going to divide out. We're going to have y to the 4th. So our final answer here is going to be the log of x to the 8th, y to the 4th. So we're asked to write this in one simple term. So what we do is we use the power rule in reverse, get the new exponents, and then divide terms out if possible. And then we remember that adding the logs is equivalent to multiplying them, and that's what enables us to write this expression down here. All right? Now, for number 8, it's pretty straightforward. We have the log of the addition here, so that's going to equal to the log. It's the same base. If it's not mentioned, it's automatically a 10 of 14xy. We can put those terms together, and that's it in one step. So the addition, so again, we're using, of course, log of AB is equal to the log of A plus the log of B. That's what's happening there. Because again, why does that work? Because we're adding exponents when we multiply. Remember, a logarithm is an exponent. Okay? A logarithm is an exponent. It's a very important thing to remember. Number 9. Okay, so right there they tell us, they give us a formula, and they tell us what I0 is, and they tell us that the density is decibel level is 152, and they want to know how intense does the sound have to be on this scale in order to have a decibel level of 152. So we put the 152 in here. That's equal to 10 times the log of I over whatever this number is. I over 10 to the negative 12. Okay. And we follow through. We can divide out by that 10. Divide it by the 10, and we're going to get 15.2 is equal to log of I over 10 to the negative 12. Okay. Well, actually, we'll bring that up and make it 12, sorry. So it's 15.2 times the log. We can bring this up of 10 to the 12th times I, because we go over the line and change the sign. Remember, a to the negative b equals 1 over a to the b. And so now we have this here we can work on. This equals 15.2 equals log of 10 to the 12th plus log of I. Alright, this is going to be 12 log 10. So 15.2, bring the power rule, equals 12 log 10. So this is going to be 1 right here. So this means we have 15.2 is equal to 12 plus log I. We subtract and we get 3.2 is equal to log of I. And in order to get rid of this log, we have to raise it to the power, because remember log is base 10. So we do raise 10 on both sides. We have 10 to 3.2 is equal to I. And then we get a really big answer. So 1,584.893. That's the intensity sound has to be in order to have a decibel level of 152, which is basically rupturing your eardrum at that point. Okay, we're asked to rewrite this term with a single term with no logs. So I'd write this out as a separate product, e to the third times e to the negative 5 ln x times e to the ln y separately. We can do that. So this is going to give us y. So we have e to the third. This is going to give us y. And this is going to give us e to the ln x. That's going to give us x. So that's going to give us x to the negative 5th. So when you do e to the ln something, it's equal to x. Remember, e to the ln x equals x. So this is x to the negative 5th times y. So we're going to have e to the third times y over x to the 5th. Number 11 here, we have ln x minus ln y, 9. So that's simply going to be ln of x divided by 9. Go from subtraction to division. Remember the term, ln of a over b equals ln of a minus ln of b. That's what we're using there now, log. Okay, so what do we have? We do this part first. So it's going to be the log of, rewrite this into exponential form, log of 10 to the 4th raised to the 250x, which is going to be to log of 10 to the 1000x. Okay, so 10 to the 1000x. And that's going to bring down the 1000, so it's going to be 1000x log 10 using the power rule. So it's going to be 1000x because this is 1. So then we have log of 1000x, which equals the log of 1000 plus the log of x, which equals 3. So it's 3 plus log x. And that's all there is for that one. Very common one. You're going to see that one on Hawks for sure.